Okay. So let me start from the beginning. Okay, let me start from the beginning. For module, okay. So let's look at from your view. Okay, from your view. You know, for student view. Okay, I'm getting to the student view from your perspective. Okay, so what you need to study. If you expect this class will do everything in every possible details, I would have to tell you it's almost impossible. It's almost impossible because this class is designed to review those key topics, okay, to prepare you for calculus class. Okay, so this class include, okay, this class include the contents. Okay, so let me just write it up. Okay, write it up. This class include the topics of pre-algebra. Okay, elementary algebra. Intermediate algebra. Okay, maybe college algebra. And trigonometry. Okay. These 5 classes in one. This class is 5 classes in one. So as you can see, it's impossible for us to do every possible details. Well, that's why we have the support class. Even combined with the support class, okay, if you are, you know, if you forgot some stuff in elementary algebra, we can quickly dash in there. We intermediate algebra, we quickly dash in there. A lot of the things we do, they're all from these classes. They're all from these classes. For example, the quiz number 4. Okay, I promise you guys, you know, yesterday we got some request. You want me to go over quiz number 4, and I'll be happy to, which is going to be tomorrow. Okay, I will be doing that tomorrow. But a lot of these studies, a lot of these exercise, I put it in the notes. You will have to take the initiative to do it. If you don't do it, and you'll be lacking in certain areas. So that's why you see in my assignment, in my homework to you, right? I will point to the exercise later in the handout. Later in the handout, the handout is designed in that way. It's that, okay, we're focusing on these functions for your entry to calculus, but you need practice to factoring. You need practice on a perfect square, completing a square. When did you learn completing a square? Elementary algebra. Elementary algebra, right? And later we're gonna review you know, logarithm exponential. Actually, we have already done that, right? Recently in the context of a function, and we will have another session to review. And yesterday, I gave you some homework on trigonometry section. Okay, I don't know if you guys noticed. Did you guys notice that? How many of you noticed my the homework assignment I gave you yesterday? So could you please look at that homework assignment yesterday? And I sent everybody a message. So to take this class and to be successful, you have to work very, very hard. Do you understand? Because this is 5 classes in one. You cannot wait for me and say, oh, I'm going to wait for teacher to catch that. No, I will not be able to do everything I put in the notes. That's impossible. Okay, unless you guys are super prepared, yes, we can. The question, the reality is you guys are not super prepared for calculus. That's why we cannot complete the notes exercise in class. You have to take a lot of initiative to do as much as you can. You should not wait for me. Okay, so the homework, so how you should use the notes. You should go, this notes is arranged in such a way that the difficult topics covered first. The latter topics are presumably to be easy. Do you follow me? The latter the contents in latter pages, okay? The content in latter pages are presumed to be easy. But if you see those exercises and you realize, oh my God, this is not easy, I got to sit down and do it, that means you need to do them. Okay, as you can see, they're about 160 pages. There are a couple of pages repeating. Okay, say it's 150 page. Okay, 155 pages, right? All of these exercises, I put them there. Is, you know, in the event, right? I still may not be comprehensive enough. In the event of you miss some factoring exercise, right? For example, I didn't give enough factoring exercise. Factoring exercise can be found in elementary algebra. Do you need factoring? Yes, you do. You need factoring in elementary algebra. You do. And yesterday we covered that, you know, 0 cannot be the denominator. When did you learn that? Pre-algebra. Okay, but we pointed out for intermediate algebra has a lot of overlap with elementary algebra. Okay, so you can see it's impossible to do 5 classes in one in detail. So as for you, you really, really need to get on the homework I assigned. That's the minimum you can do. Okay, because I challenge you, I believe that you guys, even if you pass this class, it doesn't mean you're going to pass a calculus class. Passing this class or barely passing this class only ensure you get into calculus. Do you agree with me? It doesn't mean you get out. Doesn't mean you're going to get out of calculus. You should shoot for a strong A in this class to give you some assurance that you may pass a calculus class with a decent grade. Okay, because I'm teaching this class with my mind full of how I'm going to better prepare you for calculus class. So my mindset is teaching this class so that you will be successful in calculus class. That's how I design the notes and so on and so forth. There are a lot of tiny little details. For example, can you reduce square root of 12? You should be able to, right? Can you reduce square root, cubic root of 54? Well, you have those exercises I assign you on, if you look at the assignment, they're there. Okay, a lot of our students in calculus class, they cannot reduce those. Do you guys follow me? Yes, these 155 pages look overwhelming, but if you cannot handle these, you're not going to make it to pass a calculus class because it will be even more overwhelming. Okay, so I encourage you to do as many exercises in the packet. Forget about the order. Okay, forget about, oh, we're on page number 5. Or let's only do page number 5. No, I send you to do exercise in later pages. You should go through all the pages. Okay, to say, oh, I know how to do this. Let me try a few. I don't know how to do that. Or let me try a few. I have a question. I'm going to ask the teacher. That's what you need to do. You're not going to wait for me to say, oh, we're on page number 5. And by midterm, we are on page number 25. Oh, we're so slow. We're not going to finish. I'm not going to touch those pages. Well, it's going to be your loss. You're going to be very sorry. Okay, so you must take the initiative to do it, because if you just want to barely pass this class, that's what you do. Otherwise, if you want to pass a calculus class in your mind, which you calculus class grade, which is A, if you get an A from calculus class, that's your goal. That grade will get you to the, the fabulous school you want to get to. Then you should do everything possible in this packet. The first round, you should try to do all the A's, okay? Because in some exercise, I have A, B, C, D. You should at least do all of the A's. There's some exercise I don't have the A's. I just have the title, say basic 31, just do basic 31. But sometimes I may have basic 10, A, 10B, 10C, 10D. Your first round, you should do all the A's. Okay? Because this is a collection of exercise from 5 classes. And it's not even complete. Sometimes you have, as I said, factoring, I didn't have enough exercise for factoring. You have to go back to your elementary algebra to do factoring, completing square, and so on and so forth. Okay, I will try to touch everything possible for calculus classes, but if we're slowed down, or for some reason we have to do certain things, for a longer time, then we're for sure we cannot finish the whole thing. Okay, I have modified my notes over every semester. Okay, I have never been able to finish, but it's not my fault. It's still your responsibility. Okay, still your responsibility. Okay, so do as much as you can, ask your questions. So next, I was telling you on the on the homework. Did you guys see the homework? Yesterday, I gave you the homework, right? On Monday, I sent you to basic 30 through basic 33. Those are the exercises I just mentioned, right? Can you reduce root 12? Can you reduce, cubic root of 54? Can you reduce, all kinds of, tiny little things. And as we said, the devil is in the detail, right? If you cannot do those little things, then you're going to lose points here and there in your calculus class. These 5 classes were pre-calculus as a review class. These 5 classes is absolutely the foundation of calculus. If you cannot do algebra, you can forget about calculus. Okay, now we're not in a physical setting. If you are in a physical setting, or if you have a friend who are taking calculus class right now, does any one of you have a friend who taking calculus class right now? Maybe you can ask him to take a screenshot or take a picture of what they were doing in the class. In a normal time, pre-pandemics, I was telling my student to walk in a calculus classroom to see what is on the board. Okay, so let me tell you what's on the board. If you walk into a calculus classroom, the teacher who's teaching that calculus class is going to be cover the board, okay, with what? With what? With algebra. Covered. Under the umbrella of calculus. Calculus have new concept, right? Have new stuff. Okay, I'm trying to give you guys a little kind of stimulus. Okay, so let me tell you what is in calculus class. Okay, what are you going to learn in calculus class? Hold on, I'm going to get it to you. I taught calculus class before, so I made it for my students a PowerPoint, which summarize all the definitions, theorems, and everything you need to know for calculus class. So I'm going to show you right here, right now. Okay, so this is the PowerPoint I prepared for my student, just as a summary, okay? It starts with something we know. Anything times 1 stay the same. Anything at 0 stay the same. If, if these are the flashcards you're familiar with, right? We know that, we have that. And now from card number 8, well, function, we covered function, okay? One-to-one function, increasing function, decreasing function, we covered. Even function, odd function, okay? Even function, odd function, you have learned that in algebra class. Okay, we're gonna review those topics. And composition of function, truth table, right? Next, now this is a page from number 17, okay, up to number 16. I can send you this PowerPoint, okay? Up to this point, number 17 to the end of it, 130. From 17 to 100 to 130, all these flashcards, okay, I'm going to show you. All of these are new things you're going to learn. Okay, all of these are new things you're going to learn in only calculus 1, okay? All of these theorems, definitions, and so on and so forth, all these things that you are going to learn in calculus. And every single day, these theorems definition will show up in your classroom on the board. On the board, your professor will cover the board with nothing but algebra. Because algebra is a tool to do all of these theorems, definitions. Do you guys follow me? So if you are not proficient in algebra, that's what we are doing now, which is in this packet, you're not going to survive it. You're not going to survive it, okay? Look at all these definitions. Look at all these theorems. You're going to learn. Does any one of these look familiar to you? Tell me, does any one of these pages I'm just clicking randomly, do they look familiar to you?
Not at all.
Not at all. Okay? We are in this class, okay, among the 130 flashcards. How many do? We only do 17 of them. 17 of them, you need to be able to do everything in this packet. And in addition to that, okay, this is the beginning of calculus. Everything from 17 to 130, that's a calculus class. You're going to do all of that in calculus class based on algebra. Okay, so if you don't have these foundation, okay, so all the first 17 pages we covered here, 17 pages, right? We haven't covered that point yet. We have done how many? We did up to increasing function, decreasing function, right? We haven't done even odd. Those are, all of these are reviews. You must know. And then you can jump in calculus. You can derive all of those stuff. Do you guys realize how much harder you need to work on this class? Do you realize that? A few years ago, I was on a program committee to assess our program in the calculus series. What do we have found? Okay, what do we have found? That the student who made it past the pre-calculus class, right? Suppose there's a, say, 70% pass rate. A lot of those students will not pass calculus class. There's like a cliff. You see the data, it's like a cliff. People passing pre-calculus class, that's pretty good. Okay, and then the next number is about calculus. I wish I have those graph in front of me. There's the cliff. A lot of people who get into calculus class, and in the first few weeks, they cannot float. They cannot swim anymore because they barely pass pre-cal. If you barely pass pre-cal, you should plan to take cal at least once. And you wasted time. And the root cause for not passing pre-cal, the root cause for not passing calculus, okay, for me is because you're weak in algebra. That's the diagnosis I can tell you. So if you cannot do the exercise I have in the notes, okay, a lot of them you have a hard time, I can almost be certain you are going to struggle. Okay, I'm not going to make that judgment call whether you're going to pass or not, because some people will just pull it off because they work extra hard. It's possible. Okay, you're going to struggle. You're going to struggle. Do you understand what is a struggle? Struggle. I've been through struggles. I know what struggle is. But struggling in mathematics is at a different level. Okay, so I hope I give you some ideas, and so you take it seriously. The homework I assign you, the posting I ask you to read. I don't know how many of you read those postings, how many of you do the homework, okay? At least just now I was asking you guys, did you guys know the homework I assigned you? Yes, we're online, but I assure you, one day you're gonna have to take that calculus class. It's not gonna be, it's not gonna be an easy pass. Let me assure you, it's not gonna be an easy pass. Okay, if it's easy pass, it's a terrible insult to our program. So don't count on that. You only have to build yourself to be better, to be stronger. Okay, so let me share that screen with you again. So please, because during my office hour, there's only one student asking about these exercise. Only one student, only one. Where's everybody else, right? And yesterday I gave you the homework. I sent everybody email and pronto you, so please do homework. Trick 2A, trick 2AA, and trick 4A. And these are the work which is the extension of the lecture we do. They're absolutely important to do them. I don't know how many of you are doing it. We're just at the beginning of the semester, but we're in week 3 now. You should not be surprised. Time flies very quickly. Okay, time flies very, very quickly. Okay. All right. So that was about the task ahead of you. Okay. I don't mean to scare you, but if you're not scared at all, you're slacking off. You're not doing yourself any service. You guys follow me? I was a student. I have, I was so much older than you guys. I've gone through that transition from algebra to calculus. It's very, very difficult. Do you guys understand? It's very, very difficult. It's a transition. It's a paradigm shift of how you study. The way I'm teaching you, which is, studying the words and how to do that, I'm trying to prepare you because that's how you're going to study calculus. How do you study those definitions, theorems, and so on and so on. Here, we hardly have any theorem. Okay? We only just say, oh, this is definition of one-to-one. Decide, whether this function is one-to-one. What we do is not nearly as difficult as the theorems you're going to have to handle in calculus class. Do you follow me? I'm just teaching you the methodology, the method of study, the logic behind it. You follow me? All right, do take it seriously. Okay. All right. Continue what we have done yesterday. Okay, so I keep my promise. Oh, wait. You see the screen, right? You see you see this one. Okay, the next one I want to remind you of. Yesterday we covered the sine curve, right? The unit circle sine curve, unit circle cosine curve. And I was telling you to read about it, to read my module. Where do you find them? They're here. Anybody was trying to read it? You don't have to read the module I wrote, but you can read the textbook, okay? But when I wrote this, I tried to go straight to the point. I tried to go straight to the point. For example, okay? I want you to watch this. It's a PowerPoint I personally made, okay, to show you how that unit circle we work with is made. Okay, this is something you have learned in trigonometry. And I have a presentation. I also have a posting on sine and arc sine, even though we haven't reviewed arc sine, but you have studied arc sine, right? We're getting there. So on the sine part, okay, this is my writing. Okay, this is my writing. There's a picture, there's a marking of the points, there's some writings, there's a links. Okay, the links, there's domain and range, and there's all these words and the examples. Words and examples, and arc sine or sine inverse. Okay, you should get started reading these things. Do you guys follow me? You guys follow me? And then there's the cosine, right? And then there's the cosine. I try to keep everything short, right? Examples. You should be able to understand all of them, even though we haven't reviewed those topics, because this is a review class. But if you have a question, I am the resource. I'm the resource. Okay, just come back to me, ask those questions. And next, you can see it's going to be sine, arc, cosine. You can go back to the modules. There's all these writings I have poured my time and energy into. So hoping that this is going to help you. This is going to help you. But if you don't read them, it's certainly not going to help you. Okay. All of these you probably should read at least 3 times. 3 times. If you think this is too brief, read a textbook. Read a textbook. In my writing, I usually do not write anything that's not necessary. So every sentence needs to be reckoned with. Okay, every sentence I point to something, there's no wasteful words. There are not many words that's not necessary. I wouldn't be putting them there. All right. So that was that takes quite a long time to cover this. I hope you guys are not turn off, but you really need to work with. And some of these lectures, okay, these are from my past lectures. It's about trig formula, deriving trig formula. Okay, I have a trig formula sheet. Okay, I made, once again, I'm proudly say I made this diagram. And I have these recordings showing you how they're being derived step by step. Will we have time to cover all of these? Well, last semester we didn't. Okay, the semester before we did. So in the event we don't have time to do it in class, then you should make a point to do it. To watch this. You can watch it now because you have the, you have the foundation. You have some sort of foundation when you come into this class. So that's what I assume. You have some algebra, right? So if you have any questions, and I am here. Do you follow me? So you should not wait for me to assign you, oh, hey, please read this and read that. No, you need to go over all of them. All of these. Because you're supposed to know them. If you wait for me to get there, and then you in turn you say, oh, I'm gonna blame Miss Wang because she didn't do it in class. You can say all the blame you want. Right? You can say all the blame you want. If that makes you feel better, it's not gonna help you a single bit. You understand that, do you? You understand that ultimately is your responsibility. Right? All right, I hope what I said today, I take so much time of the class time to talk about this. I hope I can get you really serious about this. All right, so I'm now gonna put it away. So let's continue to do the tangent. So today is it's March 3rd, isn't it? All right, March 3rd. Okay, so today is March 3rd. So what we did yesterday, we did a sine, we did a cosine, right? Let's see how we use the graph. For tangent, this function tangent is very much used in calculus class. So we need to know this curve very well. Okay? So how is tangent calculated? By definition, right? By definition, we know a lot about tangent, don't we? Tangent of an angle. Tangent of an angle is what? What is it that, what does the definition say? If we look at the stage set, right? Positive angle, negative angle, reference angle. Y over X or sine over cosine. Very good. Okay. It's Y over X in the setting of definition, and in the setting of sine cosine is sine A over cosine A. How is that translated into the graph of tangent? Yesterday, I was asking you guys to mark a point, right? Can you mark that point? Can you mark that point? Did you mark that point? This point, approximately. Hold on, here. Did you mark this point? What's going on? Did I share this? Sorry, did I share that? Mark this point. It's not precise, but the y value is 1. What is the x value? What is this point?
Pi over 4.
Pi over 4. Very good. Comma 1. What does it mean? We've done sine, we've done cosine. What is the implication? Pi over 4. What is pi over 4? Pi over 4 is how long this is, right? Yes? And this same length is the same as the what? The arc length, right? The arc length from here. The arc length on the unit circle. And the terminal right here. Pi over 4. And what is 1? What is 1? 1 is the blue number divided by the red number. Do you guys see that? That's the making of tangent. Do you guys follow me? And then you know how to get the cotangent. We're not going to do all 6 functions. We're really not going to do all 6 functions. But your quiz question will ask you about other functions. You know what I mean? I gave you a quiz yesterday, didn't I? It's not due immediately, but you need to work on it. Okay, you need to be able to apply them. Apply what we learn in class and to other places. So what is this height? This height. Okay, this height. Maybe I should make it turn to red. Right? Let me make that height turn into red. Right? This height. This height is 1. And what does this height mean? This height is tangent pi over 4, which is the ratio of sine, okay? The ratio, which is a sine of pi over 4 divided by cosine of pi over 4, which is, in fact, is just the blue number divided by the red number. Do you guys follow me? Now the question is, because we're studying the domain and range of tangent, and we understand that pi over 2 cannot be in the domain of tangent, right? We talked about that yesterday, yes? Now that's why we have this vertical asymptote. But the question is, in your calculus class, they want you to understand that what happens if x is approaching pi over 2 from both directions, right? Your arc length is getting closer to pi over 2. Not equals to pi over 2, never. But of getting very, very close to pi over 2. If you use degrees, yes, we cannot use 90 degree. How about what if we use 89.999 degree? 89.9999999 degree. How about that? So that's what you want to study. You guys follow me? And that we need to imagine. And the other question would be, what if I approach from the other direction to pi over 2? What happens? And it's all in the graph. It's all in the graph. What does it tell us? So every one of these is a tangent value. Okay, so this is a tangent of 60, and this is a tangent of 75, right? It keeps going higher and higher. So all these red bars are the tangent value. As we getting closer and closer to pi over 2, what will happen? It shoots to infinity. It shoots to infinity. Do you guys follow me? Remember we did a similar study for E, for log, right? And so now in calculus class, you're going to be studying these. And it gets more complicated, okay? So now let's see what happens. Okay, so what happens as x approaching pi over 2? Okay, from smaller than pi over 2. Oops, sorry. Okay, from smaller than pi over 2. And what happens? What happens x approaching pi over 2 from larger than pi over 2? So now you guys understand this notation, don't you? So what it means is that as x approaching, you see, this is what it means. This arrow is that. That arrow is this. Okay, so what you need to imagine, okay, so let's do one at a time. Let's do one at a time. Okay, let's do one at a time. So I'm going to clean this up. Let's do one at a time. Now, all of these are here, right? So we want to consider when x is approaching pi over 2 from smaller than pi over 2. What does that mean on the unit circle? Your angle measured from the standard position is getting close, the terminal is getting closer, right? It's getting closer and closer to pi over 2 from smaller than pi over 2. Do you guys follow me? Okay, so this is the scenario. Approaching pi over 2, getting from smaller than pi over 2. Okay, getting closer and closer, never overlap with that vertical line, but getting infinitely close to it. Is that infinitely close? Can I be closer yet? Yes, I can be infinitely close to it. That infinitely closer yet can only be in our imagination. We actually cannot do it physically. It's in your imagination. So in calculus class, you're going to be doing a lot of imagination. Excuse me. Okay, so suppose we are here. We're here. By definition, okay, there's a point. You can see this point is approaching that 0,1 as close as possible. But this point, what kind of point is this? What kind of point is this? Can you mark this point? Okay, so when we're now following the definition, okay, we're following this definition. On definition, we pick up a point x comma y. Okay, so we know that tangent of this angle is going to be y over x, right? It's going to be y over x. Y over x. How do we write this? Okay, so I'm going to write this down this way. Y over x. Okay, y. I have a y right there. Okay, so I'm going to just use that y. Okay, y over x. So this y over x. So as this red terminal is getting closer and closer to pi over 2 from smaller than pi over 2, what happens is the y value is getting closer and closer to 1. Okay, the y value is approaching 1. And the x value is approaching where? Where does it approach? It's approaching 0. Do you see that? The coordinate. Do you guys see that? So approaching 0, right? So this ratio, what does this ratio approach to? Then you'll be thinking, right? So let's imagine some numbers. Okay, you look at the numerator approaching 1. The denominator is approaching 0. Take some examples. Okay, 0, 0, 0, 0, 0, 1. For example, right? That's close to 0, right? When you do division of these two numbers, feel free to use a calculator or your cell phone calculator. And what you get? 1 divided by a very, very small number. What is it going to be? Very large. Do you follow me? Very large. 1 million. What if I add another 0? This time I have 5 0, right? What if I have 0.000000001? It's going to be even larger, right? So that's the process you imagine. That's why this curve from here is shoot up, because it gets as high as possible. Do you follow me? So what do you say about this? What do we summarize about this phenomenon? So as x approaching pi over 2 from smaller than pi over 2, tangent angle, okay, I'm going to use angle, okay? Angle, tangent of that angle, okay, this angle approaching pi over 2 from smaller than pi over 2, okay? From smaller than pi over 2. Tangent of that angle approaches what? Approaches positive infinity. Do you guys follow me? Okay, so that's the scenario we're seeing. I'm gonna make sure you write it down, this whole process, before I move forward, okay? The angle approaches positive infinity. The angle is approaching pi over 2 from smaller than pi over 2, right? Did you guys notice I have this little negative sign over here? Did you guys see this on the shoulder? Does everybody see that? All these notations need to be written down correctly. If you miss this little negative sign, you will be completely wrong. You follow me? Okay, we're gonna do that later. Okay, I put it on the side. So this piece, you need it in calculus class. Okay, what does it mean? It means that as the angle approaches pi over 2 from smaller than pi over 2, the ratio of tangent is approaching positive infinity. You follow me? When you write it in calculus class, please don't forget this little symbol right there. If you miss it, you'll be completely wrong. If you don't miss it, you do it exactly the way I write, you get points. So every little detail, the devil is in the detail. The devil is in the detail, indeed. Mathematical notation is very compacted, very concise. Every little thing counts. Now, so let's look at the other direction. Let's look at the other direction. Are you guys done? Okay. So this part, I'm going to box it. Okay. I'm going to make some modification. As you see, these two software don't talk to each other, right? These two software don't talk to each other. So the terminal. I hope you guys take some decent note. Okay. And over here, there's this Y here. You see when I move something, I'm gonna move, this is the Y. Okay, I make sure it's complete, okay? Do you guys follow me? And this angle approaching pi over 2 on the unit circle from smaller than pi over 2, which is here, the ratio is in the situation that the numerator approaching 1, denominator approaching 0. And in that case, it's a shoot up, approaches infinity. The ratio approaches infinity. Okay, so this tells us tangent ratio can be as large as possible. We're still talking about domain and range, right? Very good job, Kyle. Very good job, Kyle. You got it. You got it. Could you please look at the, Kyle's notes, Kyle's writing on the excellent, okay? But his notation needs to be modified, okay? But I know he write it that way because we don't have that mathematical notation to write it down. So we need to write it. I need to give you the perfect notation, okay? I will not allow myself to give you some lousy stuff. Okay? Okay. So when x is approaching 2 pi over 2 from the other direction, what will happen? Okay, so I'm going to use a green. That's the A. Sorry, I'm going to use A. Okay, sorry about that. Okay, no difference, but I'm going to use angle. A is for angle. Okay, A is for angle. Angle approaching pi over 2 from larger than pi over 2. What kind of scenario is that on the unit circle? Is that you measure the angle from the standard position still, okay? Oh, sorry. And your terminal is something like that, but you're approaching it from larger than pi over 2. Do you guys see that? Larger than pi over 2. Getting closer and closer and closer and closer and closer yet. Do you follow me? And what happened is that on the second quadrant, tangent is negative, right? Tangent is negative. So now we have a situation tangent of this angle, right? Of course, it's still equals to y over x, right? But y still approaching 1. X is approaching what? 0, but smaller than 0. So you have a similar scenario, except it's negative. So that's why it goes to negative infinity. So Kyle was exactly right. Kyle was exactly right. Very good job. Okay. And but you see the process, right? You see the process. You can see from unit circle, you can see the curve itself. And then what you see? What's the proper way to write it? right? Tangent of this angle is approaching what? Negative infinity. Okay, so here I'm going to use the word S. And this is the second piece that this picture tells us. Okay, tangent, that ratio approaches negative infinity. Okay, negative infinity. Approaching negative.
Professor, can you hear me?
Go ahead. Yes.
I just wanted to clarify, when tangent is approaching a negative infinity, it's because it's in the second quadrant where tangent would be negative?
Yes. Over here, okay. Yes. Tangent is negative in the second quadrant, right? You did the quiz, right?
Yes, just clarifying.
Right. But how you can figure that out? How do you feel? Well, that's a very good question, Jocelyn. So we all forget things, right? We all forget things, right? We all forget things. How do you figure out? Suppose in a moment of your mind is blank. Say, oh, what is the sign of tangent in second quadrant? How do I figure out? Definition. Definition. If you have an arbitrary point in the second quadrant, right? This point, arbitrary point in this quadrant, the point in this quadrant, the y is positive, x is negative, right? So y divided by x is a positive divided by negative. Of course, tangent ratio is going to be negative. Does that make sense?
Yes.
You see, this point, very good question. You see, on this quadrant, the x coordinate is negative, the y coordinate is positive. And you take the positive divide by negative, of course, tangent is going to be negative. Do you guys follow me? It can all go back to the very basic. So in that regard, you don't have to memorize. You don't have to memorize a lot of things. That's my point. You really don't have to memorize a lot of things. And that's the goal. That's another goal I'm teaching this class. I want to show you how you don't have to memorize so many things. It's overwhelming, isn't it? Right? Another question. Any other question? So you can see the picture. Now you look at the picture. Now I'm going to remove everything. I'm going to remove everything. Okay? I want you to stare at what we've done to see if that makes sense to you, if it makes better sense to you. Okay? Are you ready? Do these make sense to you? Yes or no? As x approaching.
Yes.
Huh? Does it make sense to you?
Yes, it does.
Very good. Do you see something you didn't see before?
No, it makes sense to me.
Do you think you have seen something you didn't see before?
No.
So you knew that before. It's great. If you knew that before, that's great. If you didn't know that before, now you know it, it's great. It's great as well. Okay, but I just want to point it out. Okay, so this is tangent. So not only we need to, so now we know that tangent can approach negative infinity, tangent can approach positive infinity. And all the ratios in between, right? The blue number divided by the red number, you get those ratios and many more, right? You did the quiz this class, you did the quiz number 4, didn't you? Right? You get other ratios too, right? So they're not special triangles, you still get lots of ratios. So now what do we say about the domain and range of tangent? What do we say about domain and range of tangent?
Domain cannot be any odd multiples of pi over 2.
Very good.
The range is infinity.
Perfect. Infinity, that's incomplete.
Oh, from negative infinity to positive infinity, right?
Domain, the angle cannot be odd number multiples of pi over 2. Oh, sorry. Of pi over 2. And the range, what is the range? The range is all real numbers, right? Range is all real numbers. Negative infinity, positive infinity. I think that's what you meant, right, Carlos?
Yes.
Okay, thank you. Good job. So that's about tangent. That's about tangent. And you guys are going to figure out about cotangent, secant, cosecant. Okay, they will be on your quiz. They will be on your quiz. Okay, we have covered everything. Okay, we have given you the methods. Okay, so now let's move forward. Let's move forward. We move forward, right? We have studied this sine, cosine, tangent, and cotangent will be left for you. And let's study arc sine, arc cosine, arc tangent. Okay, so before we do that, question. Is sine a one-to-one function? Is sine a one-to-one function? Is cosine a one-to-one function? Is tangent a one-to-one function? So what's the definition of one-to-one function? You see, this is the method you're going to use on a daily basis in calculus. You just be working on different concepts. Okay, we say, oh, is this a continuous function? Is this function differentiable? Right? You'll be working on those kind of concepts. Does this function has a limit here? Does that function has limit over there? And so on and so forth. But the method you use is exactly the same here. Okay, so what's the definition of one-to-one function then?
X1 cannot equal X2. And f of x1 can not equal f of x2.
No, that's not a concise. Nice try. Whenever mean x1 cannot equals x2? X1 can equals x2. Nobody said x1 can equal x2, but in the case they're not the same, their output will not be the same. Okay, you can choose two of the same points. You can choose two of the same points. Okay, you're just gonna get the same value. So that's why we use whenever, right? There will be cases x1 is equals to x2. In that case, we don't evaluate them. That's the point. You follow me? So you cannot say x1 cannot equals x2. It is the word is saying whenever. Do you guys follow me? Do you hear the difference? I feel difference. English is not my first language, but I feel it's different. There's a difference between saying x1 cannot be x2 versus whenever x1 is not the same of x2. Do you guys follow me? You have to use the right word. You have to use the right word. I'm sorry, Carlos. I appreciate your participation, but I have to, I want to, continue that discussion.
It makes sense to me now that you pointed out.
Yes, you have to use the right word. A lot of our students don't get the points because they didn't use the right word. They don't know how to use the right word because they never think about it. To me, this definition is worth 10 hours of your time. The definitional function worth 20 hours of your time. And then you only spend 5 minutes. Of course, you're not going to get it, right? It's a different way of studying. You kind of constantly think about it. You think about it. You can't say, oh, I'm going to only think about it in class, and after class, yay, I'm thinking about something else. Math is a subject that it will inspire you to think and think again and think over and over again. So your understanding of this thing is going to deepen over time. Then you say, oh, I don't care about it. I don't care about math. I hate it. Well, that's I cannot I cannot deny your feeling. But let me tell you, math was not my favorite subject. But I learned to appreciate because I have to pass it. I have to make it. If I want to make it into a decent job, and I will have to, at the time, at least for me, I realized that's the only thing I can do to change my life. Right? But you can learn this skill. What I'm telling you is you can learn this skill. It doesn't matter what your background. Because you just have to think a little bit more than you can work on yourself, in other words. We can work on ourselves to make it. Okay. So that allows you have to chew on these words. You have to think about these words. Why this is whenever? Why not? It cannot be. You guys follow me? We work on ourselves. We cannot work on a lot of others. We cannot change a lot of things in the world, but we can change ourselves, can't we? Or can't we? Right? So you need to make sure you use the right word. Precise word. Better words. Is it possible? Yes, it is totally possible. Okay, I'm a living proof of that someone as humble beginning as I came from. Right, my parents never went to college. Right? We were very poor. I only have paper pencil. That's only two I have. I made it to have a decent life. Right? You work on yourself. Here, you think about it. Okay. All right. So whenever, so I want you to use this definition to judge if any one of these functions is one-to-one. I'm going to give you a couple minutes. Okay. You use a definition to determine whether something is or something is not. We've done this before. Right? You're working hard. We're working hard on ourselves. Only paper, pencil. Only paper, pencil. Okay, you guys work on it. I'm just going to grab some pictures for myself. What do these pictures tell us? Right? How to read the pictures. How to read the pictures. Do you have an answer for it yet? For sine, is it one-to-one?
No, it's not 1-to-1.
Why?
Because whenever x1 doesn't equal x2, f of x1 equals to x2.
Okay, may I know who's speaking?
Bailey.
Bailey. Okay, thank you, Bailey. Very good job. Very good job. It's not one-to-one. It says whenever the input are different, the output should be different as well. If you look at the unit circle, okay, I'm going to tell you, you don't have to go very far to find those values, right? What are the input for sine? Angles, right? What are the input for sine? Right? Take, for example, pi over 6. Pi over 6 is one terminal. And another one, what is it? 5 pi over 6, right? This is one angle, and that's the other angle. They have the same output, the blue number. You see, on this unit circle, you have identified 2 different angles, but the same ratio. You guys see that? Do you see them everywhere? Right? Pi over 4, 3 pi over 4, right? Negative pi over 4, negative 3 pi over 4. You can see they're all over the place. They're staring at you if you know how to read it. Right? And we talk about you only need to give one counter example to say, well, this function is not one-to-one. Do you guys follow me? You just have to give one counter example. Okay. Now that's how you speak. Okay, that's how you speak it. So now you understand, but you have to put it in words to make your point, to make our point. Okay, so let me show you. What did I do? Okay, here. There. Okay. There's so many such examples, right? There's so many such examples. So I'm just going to, let's look at, someone said something on chat. Okay, no, very good, very good. Cortland, I'm sorry, I didn't check the chat. Okay, very good. Cortland said domain is any real negative infinity. Okay, I hope you refer to the tangent. Yes, Cortland? Do you refer tangent here?
That was for tangent, yeah.
Okay, okay.
Yeah.
All right. Otherwise, I have a shockwave. Okay, sorry about this. Okay, so now you can say whenever, but this time you don't need to. You're not going to say whenever. What is the opposite of whenever? It can be 4, it can be 1, right? You really need to reckon those. For x1 equals to pi over 6, I'm just quoting the examples we have here, pi over 6, right? X2 equals what? X2 equals to 5 pi over 6. But, right? You can see that x1 is not the same as x2. But sine of x1, you can certainly make this much shorter. Okay, I'm just I want you to compare this language. I want you to compare this language with the definition of one-to-one. Okay, so we have a definition. So then we say thus sine of A is not one-to-one. One-to-one function. So could you compare what I wrote down here with the definition? Am I quoting the definition? Am I quoting the definition? Of course, the writing I have on the top can be shorter. Right? Do you guys see that? But I'm quoting the opposite of definition, isn't it? The definition says whenever. Well, I have one case. Input are not the same, but the output are the same. So whenever is completely violated, isn't it? Do you guys see that? Do you see that whenever is being violated? Well, whenever is violated by how many cases? We only need one. Very good, Corbin. We just need a violation once. If there is one, do you guys hear the logic? You're going to be doing this a lot in calculus class, okay? May not be for one-to-one. It's going to be for continuity, differentiability, limits, and so on and so forth. That's right. Mikhail says, is 5 pi over 6 supposed to be x2 or also x1? Oh, sorry, x2. Thank you. Thank you for spotting that. You know what? I made it too long. I really made it too long. Okay. Because I can just simply use this example. Okay. I can just say sine of pi over 6 is the same as sine 5 pi over 6. Much shorter. Sometimes you don't have to make it so long, right? You can say because, and then sine function is not 1 to 1. You follow me? So all these are different ways of saying it. I'm not saying one way only to say certain things. There are many different ways, but you have to really reckon what you're saying. You have to really reckon what you're saying. When I was teaching calculus class, a lot of students, they keep telling me, I understand, but they keep losing points. They didn't use the right word. They didn't know how to say it. Right? How do we assess you? How do we give you points if you use the wrong words, and your wrong words meant something to the reader? You follow me? So you have to use the right sentence, right words. Okay, so how about cosine? Right? So now you know how to use this unit circle, right? You see this unit circle, been using it for 3 days at least, right? The 3 days. And every time we discover something new. This illustrates sine is not a 1 to 1. Now let's look at this one. Let's look, how do we use this picture to illustrate sine is not 1 to 1? Right? So what I'm going to do, I'm going to draw a horizontal line. I'm going to draw this horizontal line. This horizontal line touches the curve how many times? As many times as you want. What is this point? Right? If we know how to read these points, what do these 2 points mean? What is this point? The first one is 0, 0, input, output. The second point is what? Pi, 0, yeah? You follow me? Different input. X1, X2, different. Same output. You see that? So that a picture tells you it's not 1 to 1. Do you guys follow me? That is so-called horizontal line test. You follow me? A lot of my students, they know horizontal line test, but they don't know what it means. So now I hope you know what it means. Different input. This is X1 and this is X2. The same output. So there are many counter examples to counter, sine is 1 to 1 because sine is not. Do you follow me? Does everybody follow me? Can you do the same? Can you do the same for cosine, for tangent, cotangent, secant, cosecant? I will not be doing those things with you in class. You need to do it after class for yourself. That's called a study. That's called a study. Okay, that is expected of you. That's all I ask of you. Yes? That's all I ask of you. You know it, right? You know it. That's the expectation. Okay, I do 1, 2, 3. You're gonna do 1, 2, 3, 4, 5, 6. That's what all professors ask of their students. If you know the trick of success in academics, that's the trick to success. Hard work. Professor do 1, 2, 3. You do 1, 2, 3, 4, 5, 6. Maybe 7, 8, 9, 10. If the professor do 1, 2, 3, you do 1, well, you're not gonna make it. Okay, so can we put this together in the language of mathematics? This picture I just drew here, right? We drew the picture. How do we summarize it? Using the language, quoting 1 to 1. How do you say it? What do you say? You will say, because sine of 0 is the same as sine pi. Thus, well, sine of A is not 1 to 1. And there's the picture and there's the words. You can express what the picture tells you in words, and you can illustrate the words in picture. That's what we're trying to do. Okay. Do you get it? So understanding the picture is not enough. You have to be able to verbalize it. Verbalize it. Okay. All right. So sine is not 1 to 1. Therefore, we know cosine is not 1 to 1, right? Tangent is not 1 to 1. Cotangent is not 1 to 1. Secant is not a 1 to 1. Cosecant is not 1 to 1. Okay, how do you say it? The same way. The same way. Okay, the same way as this example I have shown you. Okay, so I've done 1. You're gonna do 1, 2, 3, 4, 5, 6. Yeah. Can you do that for yourself? Yes.
Yes.
Where's Carlos?
Yes, we can do it.
Yes, you can do it. If you can, you must, right? If you can, you must. If you can, you must. Okay. The next question is, if sine is not a 1 to 1, how come we have sine inverse? Inverse doesn't exist, right? If sine doesn't have it's not a 1 to 1. Okay, let me write down the question. So now we have answers to this question. Okay. No inverse. No, not. They're not 1 to 1. If they're not 1 to 1, they don't have inverse. In fact, sine, cosine, tangent, you could say, do they have inverse? I said, no, they don't. But where did we get a sine inverse, cosine inverse? What's going on? Right? What's going on? Is it don't exist? Okay. So now, the idea to create a new function okay, such that the new function is 1-to-1, and then has an inverse, that has an inverse. The idea to create a new function based on sine, based on the existing sine function. Okay, so how do we create it? Okay, we're close to the end of the class, but I'm going to give you the idea. Okay, from two different perspectives. Okay, the first perspective is the unit circle. The second perspective is the curve. Okay, on the curve, okay, we start with the curve first. Okay, so we have a -3, okay, over here. On the curve, we decided to chop off some of the curve, some pieces of the curve. I'm going to chop off. You know what chop off is? Chop, 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 right? Chop. Chop, chop, chop. How do we chop it? Well, there's a point here, the lowest point here. Okay, I'm going to mark this lowest point here. Okay, you guys are supposed to mark this point. Can you mark this point? Can you mark the highest point? Okay, can you mark these 2 points? Cosine curve is pi/2, comma, -1. Input output. The next point is, oh, sorry, this is -pi/2. Okay, sorry about that. Pi/2, +1. Okay, so I need to redo this piece. Okay, so one piece is -pi/2, comma, -1, and the other piece is pi/2. Now, what is going to be chopped off? Chopped off. Cut, 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 cut. You follow me? Cut. All chop off. So we have this piece left. And this piece corresponds to what in the unit circle? And what is the mathematical expression of it? Right? It's easier to understand the graph, but what is the mathematical expression of these chop, chop, chop? Okay, so if we only have this piece left, how is that translated to the unit circle? Which part of the unit circle is being chopped off? In other words, which part of the unit circle will be chopped off? I'm going to leave this question for you to think about it. Okay, this class is all about thinking. And everything has to make sense. Okay, if there's something doesn't make sense to you, you must ask me. Because that means I haven't explained it to the point it makes sense to you. And I will make it make sense to you. Kyle says x larger than 90 degrees is gone. Very good. Okay. I prefer you use pi over 2, but that's okay. We chopped so many things. No, don't apologize, Kyle. I'm just teasing you. Okay, but do try to use radians. Okay, do try to use radians. So this chop, I'm sure you might have learned it somewhere, right? What will happen to the other? What happened to the unit circle? There's a consequence on the unit circle, okay? I want you guys to think about it. I want you to think when you're eating lunch. I want you to think when you're taking a nap. I want you to think when you're walking your dog. I want you to think when you're jogging somewhere, or I want you to think about it. Is that too much to ask for? How do you think when you're taking a nap, right? She's being ridiculous. I'm being ridiculous. But anyway, think when you can. Okay. I will see you guys tomorrow. Okay, so tomorrow is Thursday. I will cover quiz number 4, and you know, we're going to also cover the inverse functions and so on and so forth. We're going to try to do as much as possible. But today, you know, certainly I want you to apply what we learned today to, you know, to quizzes, right? And you should have another quiz coming up this week, which is be closely related to the lectures. All right, so I see you guys tomorrow. I will be in my office hours momentarily. Okay, so you're all very welcome to come. And any question, you can ask me any question. Okay, anytime. Don't hesitate. Any suggestions, right? You know, anything that you feel I should be doing, just bring them up. Okay, bring them up. Anything. I do mean anything. Okay. So I'll see you guys tomorrow. I'm going to open up the office hour link. And have a great day. Is it going to rain? I heard it's going to rain.
It's raining right now.
I love it.